Hi all, this is Ritvik and I'll be showing you the demo of my in-class programming exercise for deep learning. So in this, we'll be doing an image classification on the handwritten MNIST datasets. So the programming exercise is to use the history object and plot the loss, accuracy as well, and then take one of the image and then do an inference on it and also modify the image. Modify the model. So let's see that. Import the required modules first. Let's load the dataset and see a sample image on it. We use matplotlib for this. So once that is done, we process the dataset. That is, we split the dataset based on train data and test data, and then we convert the data to float and scale the values. That is a kind of normalization, and then we convert to categorical data for the train labels and the test labels, as the model only takes the integer values. Now we create a model. This is the given code by the TS. So the first layer is a dense layer with 512 parameters. 512 is the size, and activation is the ReLU. And then in the final layer, here we see that it has 10. That is, we are going to predict 10 numbers, that is 0 to 9, 10 digits. So that is the reason we have an output shape of 10. So the hyperparameters here are the batch sizes of 256 and epochs of 20. So it took about 5 minutes about training, and let's see, it was running on 20 epochs, and the accuracy is close to 98, that is 97.9 here. Now we plot those details here, so you can see the training loss and the testing loss here, how they vary from each other. Then this is the model summary saying the total number of parameters of 600,000, which is too high. So now we create another model, which is my in-class programming exercise. We modify the parameters and the shape of the model. So I have removed the other 512 parameters from here and added 256, and then instead of ReLU I used another layer with a tanh, because tanh, from the class notes from the lecture we understood that tanh is used for classification as well. So you could also try with the sigmoid. I just tried with tanh. So once we train it, I have modified the batch size of from 256 to 512 for a faster training. Just was lazy enough to wait for it. But the strange thing is, even though the batch size is increased and the number of parameters are reduced, it was 600,000 in the previous model, and here it is about 500,000. So even with those changes, I have got a good accuracy here. Just 98.3, slightly zero point 0.4 more than the previous model. So now we do an inference on it, take a test image, which is number 7, and we predict the classes for the same image. We see that 0, 1, 2, 3, 4, 5, 6, 7. So 7. Also you see the 7 has a greater number, and we plot the same. So we plot this particular value in the histogram just to show that the 7 has a higher probability. That's it. And if you want to try, just use the same code and plot the results with sigmoid instead of tanh. Thank you.